Hi, welcome to Math Factor. This is the first episode of our Grade 7 series. Our topic for this episode is Introduction to Sets. To start with, let us first define a set. A set is a well-defined collection of distinct objects. The following are examples of sets. First, the set of odd numbers from 1 to 10. Second, the set of even numbers between 1 and 10. Lastly, the set of prime numbers from 1 to 20. We can write sets in different ways, but the most common is the roster notation. In this form, we will use a capital letter to name the set, followed by an equal sign. Then we will use braces and write all of the defined objects in it. Let us write the following examples in roster notation. For our first set, the set of odd numbers from 1 to 10, we will use capital letter A to name the set. This is followed by an equal sign with braces and all of the defined objects in it. The defined objects are 1, 3, 5, 7, and 9. For our second example, the set of even numbers between 1 and 10, we will use B to name the set with numbers 2, 4, 6, and 8. For our last example, the set of prime numbers from 1 to 20, we will use capital letter C with numbers 2, 3, 5, 7, 11, 13, 17, and 19. The most common problem in set is to identify when is a set well defined. To answer that question, a set is well defined when it is clear that an element belongs to that set or not. So let us use these examples and identify whether they are well defined or not. For our first example, the set of teachers in a school. This is well defined because all the teachers in a school can be identified. Second, the set of beautiful paintings. This is not well defined. It is not well defined because it is subjective. A painting may be beautiful for one person but not for another. For our third example, the set of large numbers. This is also not well defined because it is also subjective. A number may be large for one person but not for another. Lastly, the set of barangay in the city of Malolos. This is well defined because we can identify all the barangay in the city of Malolos. To continue with our discussion, let us define some terminologies related to sets. The first terminology that we're going to discuss is elements. Elements are individual objects or members of a set. In our given set C, the elements are all the numbers inside the braces. Therefore, 2, 3, 5, 7, 11, 13, 17, and 19 are all elements of set C. In set D, the elements are A, F, G, 1, 2, and 3. The next terminology is cardinality. Cardinality refers to the number of elements in a set. In set C, there are 8 elements. Therefore, the cardinality of set C is 8. In set D, the cardinality is 6. Next is equivalent sets. These are two sets containing the same number of elements. In set A, there are 4 elements, namely 1, 2, 3, and 4. In set B, there are also 4 elements, namely A, B, C, and D. Since they both have 4 elements, we can say that set A and set B are equivalent sets. Next, we have equal sets. These are two sets containing the same elements. In set A, it has the elements 1, 2, 3, and 4. In set B, it has the elements 4, 3, 2, and 1. Although the arrangement is not the same, the two sets use the same elements. Therefore, set A and set B are equal sets. Next is the universal set. It is the set of all the possible elements of a given problem. So suppose the problem states the set of all numbers from 1 to 20. The roster notation for this problem will go as follows. So this is a universal set. The empty set. It is a set containing no elements. Empty set is also called the null set. We can write it as two braces with no elements inside or using the null symbol. Empty sets are always considered a subset of any set. To elaborate more on empty set, we have this question. Is the given set an empty set? The answer is no, because the number 0 is considered an element of the given set. So for us to determine that it is an empty set, there should be no elements inside the braces. A subset. A subset states that if elements of one set is contained in the elements of another set, then the first set is a subset of the second set. For example, we have set A and set B. Since all the elements in set B is present in set A, we can say that set B is a subset of set A. But set A is not a subset of set B because set A has more elements than set B. Again, given set A, let us determine if the following sets will be its subset. For set B, it is a subset since all of its elements are contained in set A. For set C, it is not a subset because 21 is not contained in set A. For set D, as mentioned in empty sets are subsets of any set. In addition to this, any set is a subset of themselves. Therefore, set A is a subset of itself. Next is a proper subset. It is a subset that is not equal to the main set. In other words, proper subsets should always have fewer elements than the main set. In our example, we already know that set B is a subset of set A. But since set B has fewer elements than set A, it makes set B a proper subset of set A. And lastly, we have power sets. Power sets are the set of all the possible subsets of the original set. We will use P parenthesis the letter or the name of the set and then close parenthesis as the name of the power set. For example, we have the set A with elements 1, 2, and 3. The trick in getting power sets is to first identify the sets or the subsets containing one element, followed by the subsets with two elements, and so on until we reach the subset equal to itself. And lastly, the empty set. For subsets with one element, we have 1, 2, and 3. For subsets with two elements, we have 1, 2, 1, 3, and 2, 3. For subsets with three elements, that is 1, 2, 3. And lastly, we have the empty set. So to write this as a power set, we will use P of A, since we are using set A, followed by all of the listed subsets. So we have 1, 2, 3, 1, 2, 1, 3, 2, 3, 1, 2, 3, and empty set. So this is how we're going to write a power set. Example, using set B with elements 3, 6, and 9. For subsets with one element, we have 3, 6, and 9. For subsets with two elements, we have 3, 6, 3, 9, and 6, 9. For subsets with three elements, we have 3, 6, 9. And lastly, the empty set. For our power set, since we are using set B, we will use P of B. Then we will write all of the subsets as its elements. We have 3, 6, 9, 3, 6, 3, 9, 6, 9, 3, 6, 9, and empty set. So this is the power set for set P. Example, we have set C with elements 2, 4, 6, and 8. For subsets with one element, we have 2, 4, 6, and 8. For subsets with 2 elements, we have 2, 4, 2, 6, 2, 8, 4, 6, 4, 8, and 6, 8. For elements or for subset with 3 elements, we have 2, 4, 6, 2, 4, 8, 2, 6, 8, and 4, 6, 8. For subsets with 4 elements, we have 2, 4, 6, 8. And lastly, our empty set. So since we are using set C, our power set will have P of C followed by all of the listed subsets. So we have 2, 4, 6, 8, 2, 4, 2, 6, 2, 8, 4, 6, 4, 8, 6, 8, 2, 4, 6, 2, 4, 8, 2, 6, 8, 4, 6, 8, 2, 4, 6, 8, and empty set. So this is the power set for set C. And that is all for our first episode. Thank you for watching. Please like and share this video. Don't forget to subscribe as well. Comment down below if you have any questions regarding this lesson. See you on our next episode. Bye!